Good morning. Today we'll be learning how to use kinematics. Kinematics are the mathematical tools used to describe motion in terms of displacement, velocity, acceleration, and time.
Flippin' physics.
The variables used for linear motion are displacement, acceleration, time, velocity initial, and velocity final. With these variables, we can utilize the kinematic equations. Camilo, can you tell me what are the three kinematic equations?
The kinematic equations are displacement equals the sum of half the acceleration multiplied by time squared and velocity initial multiplied by time. The next equation is final velocity is equal to initial velocity plus acceleration multiplied by time. The last equation is final velocity squared is equal to initial velocity squared plus 2 times the acceleration multiplied by the displacement.
As you can see, the kinematic equations only ever have 4 variables in each one, meaning you only ever need 3 to solve for the rest of the variables.
Nice!
Alright then, let's try an example. Alright, let's say we drop a 3 kilogram object. 3 kilogram object from 5 meters. 5 meters. Yeah. How would we use the kinematic equations to calculate for the time it would take to reach the floor? Air resistance is negligible, as always.
Well, first we can write down all the data given to us. We know that the initial velocity is 0 since the object is initially at rest. We also know that the total displacement is 5 meters. And since the object is only moving vertically, its acceleration is equal to the gravity due to Earth, which is just 9.8 meters squared.
Correct. Now all we have to do is plug it into the right kinematic equation, which is this one. So when we plug that in, we get 5
equals 1 half 9.8 squared times 20 equals plus 0 t.
Because velocity initial, which would have been this variable, is 0, anything times 0 is 0, so that cancels that out. Then you get 5
meters equals about 4.9 times squared divided by 4.9.
yeah, 5 over 4.9 equals times squared, so square root time equals about 1.01 seconds. Alright, that was kind of an easy question, so let's try a harder one. Let's say, on a basketball court, the net is about 2.97 meters tall. Sorry about that one, it's not a great drawing. The 3-point line is about 6.5 meters away.
And someone shoots the basketball at about 1.34 meters.
Yeah, 1.34 meters. That's where he lets it go. And it does an arc and it makes a perfect switch. Yeah. Yeah. That is 2.97, remember that. So it takes about, let's say it takes about 5 equals 1.24 seconds. Yeah, it's on Earth, obviously. Or I guess not obviously. Could have been on Saturn. But yeah, what's the first thing we should do? What's the first thing we should do?
The first thing we should do is break it into its components and see what data we already have. In the y direction, we know the displacement, acceleration, and time. For the x direction, we also know its displacement, acceleration, and time.
Okay, good. Now we can use these to just plug it into this equation. That's not good. This one. Those are the components. Yeah. Now using these answers for the components, we can use the Pythagorean theorem to find the velocity vector. There you go.
Bruh.